Okay, this is the Chapter 6 review. This is beginning with Section 6.1 on page 358, using similar polygons. So let's take a look at similar polygons and review what those are. Similar polygons. They're not congruent. They don't necessarily have the same size. They can be the same size, but they don't have to be. But they do have the same shape. Now what this means, all angles, all corresponding angles, are congruent. They have the same size. All corresponding sides are proportional. In other words, that means they have the same scale factor. You compare two sides that correspond to each other in the two shapes, and then you go to two other sides that correspond. They're going to have exactly the same ratio, whatever that is. Now, you don't have to be given any shapes. You can just be saying two polygons like A, B, C, D, E is similar with, let's go V, W, X, Y, Z, right? So they're pentagons. And we've just been told that they're similar by the similarity sign here between them. Well, it may ask, list the angles that are congruent. Well, A is going to be congruent with V. So A is congruent with V because the angles corresponding are congruent. Well, another pair of angles that correspond, angle B with angle W. So angle B is congruent with angle W. Then we can go to C, congruent with X. D, congruent with Y. And finally, E is congruent with Z. All five of those angles, you just look by the position, and we did this for congruence as well. So this is not really different. But now then, for the similarity part, we've got some ratios. Well, I'm going to take these first two together, AB, that's one segment. That's got to correspond to VW, which means that ratio, AB, compared to VW, is the same thing as, well, now I'm going to take the next two, BC and WX, as the length of BC compared to the length of WX, which is the same, and we just keep going. CD compared to XY, which is the same thing as DE compared to YZ, which is the same thing as AE. We can go back and take the first one with the last one as the same thing as VZ. Those are exactly the same ratio all the way through. Same scale factor. Now, that's the majority of Section 1. Once you know what the scale factor is, you can draw any length that corresponds. If it's an altitude, perimeter, median, whatever, if you draw that, it's going to be the same between the two. Now, after this, we skipped Section 2. We didn't do Section 2, but we did go to triangle similarity. And we have three ways of proving that two triangles are similar. Well, what are the three ways of proving triangle similarity? Well, the first one is just angle-angle. Angle-angle similarity. If you have two triangles and you can show that two angles of one triangle are congruent with two triangles of another, then those two triangles are similar because of angle-angle similarity. They might be congruent if you know something about the side lengths being the same, but they don't have to be. They do have to be similar. The other two, you do know some sides. So side angle side similarity. That's one of the other two. In other words, you have the included angle, whatever that is. The two angles are congruent between these two triangles. But the sides are in the same scale factor. So the sides from the big one to the small one, big one to the small one twice, are going to be the same scale factor. Then the last one is side, side, side similarity. In this one, you don't know any of the angle measures, but you do know the side lengths. And if the side lengths are all the same ratio from one to the other, then these two triangles are similar. An easy way of seeing some of these are back from our Pythagorean triples that we had later. If you have a triangle that has side lengths of 3, 4, and 5, we know that's a right triangle because that's a Pythagorean triple. Well, if you have a 6, 8, 10, well, we said this is in the same family, 6, 8 to 10. Those ratios are going to be the same. 3 is to 6. That simplifies to 1/2. That's the ratio of those two sides. That's the same as 4 is to 8. Again, 1/2. 5 is to 10. Also 1/2. These are our three ways of proving that two triangles are similar. Right? And those are the only ones that we have. And that was sections 3 and 4. On the bottom of page 384 is a little chart that has all three of those methods together. It's good to know. Then, section 5, we have triangle proportionality. If you have any triangle, like such, and you draw a line that is parallel to one of the sides, I'm making this red one parallel to this bottom. Well, the segments that are cut off, let's say A, D, B, and C. The segments that are cut off on these two sides of the triangle are proportional. In other words, A is to D as B is to C. Those ratios are the same, right? And so that's the way that we would handle that. That's the triangle proportionality theorem. The converse on page 391, which is the opposite, says if you know that the ratios are the same, then you can say that the lines that are drawn, that one is parallel to the third side. All right? And that's the first part of section 6.5.